where I did an introduction to this, and we were solving these exponential equations when we don't have the option of getting a common base. So we did some, and what was our strategy? What did we add on each side? A log. And we really have two options. We can do log base 10 or the natural log because both of those buttons, bless you, are easily accessible on the calculator. It doesn't make a bit of difference. But let's take a look at this problem. So is it possible to get a common base between 5 and 8? No. So we add our log on each side. I'm just going to do log base 10, so I don't even have to write the base. Now, what happens after you add these logs? Bracket your notes from yesterday if you need to. After we add the logs, what did we do? With the exponent. Properties of logs, the exponent comes down. Now this type of problem, I'm going to tell you the majority of people make a mistake right here. Because what I just wrote down is wrong. Why? We need parentheses around these exponents. We brought down the whole exponent. So we need to put it in parentheses. Because what am I going to have to do on this step? Probably not even yet. Because I have x's on both sides. These are all times the log. We need to distribute? So, it's going to be a little bit of writing, but we can handle this. Log of 5, that just represents a number. We're not touching the 5 here. So this just goes in front. So we have 2x log 5 minus 3 log 5 equals x log 8 plus 1 times log 8 is just log 8. I'm trying to get x by itself. I currently have an x here and here. So I want those terms on one side, and these terms don't have x's, so I need them on the other. So it's okay with you guys. I'm just going to do this all in one step. So I have my 2x log 5. I'm going to subtract over the x log 8. Over here we had the log 8, and I'm going to add over the 3 log 5. On the left, what do we need to do? Are those like terms? Can I actually subtract them? No. What do they have in common? X. So we're going to factor out that x. If it makes you feel better, these are the longest problems in this whole chapter.
Okay, that's good.
So now to get x by itself, divide by all of that. So I get log 8 plus 3 log 5 divided by 2 log 5 minus log 8. All right. The other problem that I see with this is putting it in the calculator. Every time you push the log button, it will open a parenthesis. You have to make sure you close it. And you are also going to need a set of parentheses around the entire numerator and around the entire denominator. So type it in exactly how I have it written up here with those parentheses. questions right there? If this were a test and you thought you made a mistake, how would you check it?
Plug it back in.
Plug it back in. These are going to be off slightly because we have some rounding error, but it should still check out. All right, any questions on that? Let's do another one like that because it's kind of long. Okay. First step is what? We need our log. Would you guys be upset if I go ahead and brought down my exponent when I did that? Just make sure when you put it in front, you put parentheses around it. And this is a log of 0.4. Don't lose your decimal there. All right. Can you guys finish it from here? Why don't you try it?
Yeah.
Try it. See how far. Distributed your logs first. Moved all the x terms with an x on one side, everything without it on the other. Factor out the x, and then divide. When you type this in, you need parentheses. Every time you push the log, you have to make sure you close those, and then around the entire numerator and the entire denominator. And we get negative 0.2357. See? Told you you could do it.
Absolutely.
All right, if you didn't get that, do you need me to look at yours? Very likely, if you had this, just dropping a parenthesis does make a huge difference when you go to type it in your calculator. So please, test and quizzes, write down this stuff so I know what you're plugging in so you can get all the credit for solving it correctly. You just made a mistake putting it in your calculator. All right, let's try some more. What should I do here? Combine. These e's are multiplied. So what do you do with their exponents? Add them. So 2x plus 1 plus negative 4x. So we get negative 2x plus 1. Then what do we have to do? Add a log. This is the one scenario where a natural log might be beneficial, and here's why. If we ever have, remember the property, it said like log base A of A to the R power just equals R, because the log and the exponential are inverses. The log base A and the A cancel. Natural log just means log base E. So log base E of E, that would just cancel and give me a negative 2x plus 1. I can't do it on this side because I have a 3 attached to that E. Now, does that mean that if you didn't cancel it, you're wrong? No. You can still go through and plug it in your calculator, and natural log of E is just equal to 1. So you'll work through it. It'll just be dividing by 1 later on. It won't change your answer. If you did log base 10, it's still going to work. This is just a shortcut because we do have a natural log button. That's the one case where I like to use natural logs because those just cancel out and make our problem a little bit nicer. So then to get x by itself, we just have to subtract over the 1. And that doesn't go inside my parentheses, it's on the outside, and then divide by negative 2. So when you type it in, you need an extra set of parentheses around the whole top. Depending on, there's a couple different E buttons you can use on your calculator. If you do the one above the natural log, it automatically asks for an exponent. If you do that, just put in an exponent of 1 on that E. Second, and the natural log button. You add your log, so the negative x comes down. So you divide by a negative log 8, and what did you get? Yep. So that one's okay? Alright, this one. Did you add log or natural log?
Natural.
Okay. Not wrong if you used a log. Whoops. Said one and wrote the other. Just saves you a step if you use the natural log. Because a natural log of E is just 1. So that could just cancel. Again, if you didn't cancel it, you're okay. It'll work out in the end. So we have the natural log of pi minus x natural log of pi equals x natural log of E. But you could just recognize that the natural log of E is 1 and take that away. If we get our x's on one side, what could you do then? They both have an x, so we could factor it out. So x is the natural log of pi divided by 1 plus the natural log of pi. And we get 0.5337. Is that one okay? C might actually be the easiest one.
I didn't get there.
Don't agree with that one. What would you do first? Subtract the 1. Okay, order of operations. We have to do exponents before we can multiply. So I can't take 5 times 1.2. So what do we do with it? Alright, did anybody catch what happens right there?
No.
Yeah. 6 divided by 5 is 1.2.
Oh.
Do we need logs?
No.
No, we have a common base. You can set the exponent to equal.
Oh.
That's real.
Almost got that.
Yeah, no, if we would go.
I just rushed you.
Yeah.
What it was.
We were still
Sorry
trying to
about
figure out
that. Would you like for me to give you another one so you have the opportunity?
okay.
No.
We just started on.
We just spent too much time writing out all pi.
Yeah, we wrote down every digit,
We're such overachievers.
straight from memory.
Which digit did you stop on?
9.
7, actually.
Okay.
Last digit. I
One
remember.
of the 9 that are part of it.
Well, you know, if you go up and look at the background of the poster, like that light green is actually all more digits of pi.
Oh my lord.
Keeps going.
Oh.
I have those memorized too.
Okay.
Can you?
Maybe for Pi Day, you can recite